Hello, this is lesson 5.4. Today we're going to talk about parallelograms. So let's remember the definition of a parallelogram. So take a moment, write down what you think is the definition of a parallelogram. So by definition, a parallelogram is quadrilateral with two sets of parallel sides. And we can see the parallel sides that are marked. So it's the opposite sides that are parallel. These are parallel. It has one marking or one arrow, and then these two are parallel, having two arrows. All right, so if you don't have a ruler, I've said that again, sorry. If you have a ruler at home, find a ruler or something to measure. If you have a protractor, you can get one of those too. So take a moment, on a piece of paper, draw a parallelogram. The easiest way is to take a ruler and draw sideways lines using the lines of your paper. Then take a ruler and measure the lengths of the sides. What can you conclude? So pause, do that, and then come back. All right, so hopefully you discovered that this side is equal to that side, and this is equal to that. Now, what makes it a property and not a definition is that you can prove it. And remember that definitions have to be biconditional. So the converse would have to be true as well. So can I prove this? Yes, we can. We can prove this. I'm not going to right now, but be prepared to, or try to do it on your own. All right, so now that we know the opposite sides are congruent of a parallelogram, and listen to that word opposite, right, across from, what can you conclude about the angles of a parallelogram? Now, if you have a protractor, you can use that. If not, maybe we can just do some logical thinking using some deductive reasoning. So can I prove angle A is congruent to angle C? All right, let's try. Now I know that if I can prove the two triangles congruent, I can prove angle A is congruent to angle C. So I know that we had just said the opposite sides of a parallelogram are congruent. So I know those are congruent. I know this is congruent. So far, two sides, right? And I'm trying to prove this triangle is congruent to this triangle. Okay. And you're like, but Miss Mendoza, you missed something. I did. We also have this other side. So are the two triangles congruent? Yes. Now there's many other ways to prove it. It's not just side, side, side. But once you have that, I do know that this angle is congruent to that. Now I can do the same thing for angle B and D, and I can draw the diagonal the other way and prove that as well. Okay. Now, if the opposite angles are congruent, what about the consecutive angles? So this one is congruent to this, and this is congruent to this, right? So then we have the opposite angles are congruent. But what about angle A and B? What do we know about them? And angle D and C? Well, if you remember about parallel lines, let's see, right? Cut by a transversal. Angle A here and angle B are on the same side, so they're same side interior angles or consecutive angles, therefore they're supplementary. Now I love about parallelograms that it does pull a lot of knowledge, things that we've learned in the past, especially about parallel lines, and we can apply it to this polygon, right? I know, note that I'm not writing a lot of stuff down. I'm hoping that you are writing those important things yourself. All right, so read that, take a moment, try to do that. So pause, go find some stuff. I know it's not the same, we would have done this in class. All right, so hopefully you have this. So measure AE, EC, DE, DBE. Now if someone says, oh, diagonals are congruent. Are they? They aren't. To do a quick counterexample, if I had something like this, you can see one diagonal is much longer than the other one. So they're not the same length, but I asked you to measure each part. So if you measure the part, this equals that. So E is the midpoint of AC. What about BD? Yes, that turns out to be that. So what do they actually do to each other? They bisect each other. I can write that one down. So the diagonals of a parallelogram bisect each other. Again, could we prove that? And how would you prove that? All right, so take a moment, learning all those things that we just figured out about a parallelogram. Fill out all the variables. They're in blue. Okay. All right. So we know the opposite side. So this is 35. So this is 35. This is 82. This is 82. Opposite angles are congruent. This is 143. This is 143 degrees. Now W, you can do it a couple different ways. I can find this angle here, and we know that it is congruent to this by, what's the reason? Right? Alternate interior angle theorem. Or I know these two plus this is 180. So which is really the same thing because I just said those are congruent. Okay, so I'm going to add those two together and I'm going to get, and I'm going to believe that's 9. I think that's 9 degrees. 9 degrees. Okay, I'm just going to double check that. When in doubt, double check your work. Make sure I added correctly. Also, that is good habit for you. Yep. 180, and there you are. Okay. So for the EQ, please make sure you complete these sentences. Yes, I want you to have complete sentences in your notes. All right. Thank you for watching. Bye.